Spencer, one of my kids, is doing online courses at university and is also doing auditions for podcasts, for performing in podcasts. So they went out and bought a $400 headset. Puts mine seriously to shame. Yeah. All right. So start recording. Okay. So on Friday we looked at linear scale factor and area, and we discovered that there's a relationship between the linear scale factor. If you square it, you get the area scale factor, and that's what all the practice this weekend was, right? With perimeter, you use the linear scale factor because you can measure perimeter with a string. It's a linear measurement. With area things, you measure those with little squares of paper. It's an area, so you need to square your linear scale factor to do that. And so this next part, 1.3, we're just going to talk about surface areas. And okay, can we predict the relationship between the linear scale factor and the surface area scale factor?
Isn't this like square root law?
Not yet. Not yet. So let's do some calculations, okay? So the original 1 by 1 by 2 rectangular prism, I should not use my pen for this, which is the smaller one here. Oh, let's see if I can get my pen working properly. Nope. Let's try it again. There we go. Okay. So that's the small one, is the original one, okay? And it's enlarged by a factor of 2. So this direction, which was 1 wide, is now 2. So maybe I'll color those in yellow. So that's twice as big. And this one was 2, and it's now 4. And the height was 1, and it's now 2. So everything's doubled, okay? So the surface area original is the end has an area of 1, and then going around the sides, it's 4 times 2, because there are 4 sides that have an area of 2 each, right? Like the top, the bottom, the left, the right have all got an area of 2, and the other end has got an area of 1. So our total surface area of the original shape is 10. Is everybody okay with that? Max, you okay with that? Okay. And then the surface area of the image, well, this time the end has got 4. There are 4 sides that have 8 squares on each of them, right? There's 1, 2, 3, 4, 5, 6, 7, 8. And then there's the other end has got 4 for a grand total of 40. And scale equals image over actual. Yes? Oh, thank you. Scale is image over actual, which is 40 over 10, which is 4. So the surface area scale factor is 4. And we know that the linear scale factor was 2. So it looks like the surface area scale factor is the linear scale factor squared. That would make sense because it's just an area, right? It's just an area that's folded up into a shape instead of being flat on the ground. So let's try another one where we're using a linear scale factor of 4. So for example 2, or exploration 2, this time the prism has been enlarged by a factor of 4, so that means the linear scale factor is 4. So we have those equations where image is the original times the scale, or the scale factor, right? We've been using that. So we can have that the surface area of the image equals the surface area of the original times the scale factor. And in this case, our scale factor, we're using an area scale factor, which would be the linear scale factor squared. So the area scale factor is going to be 4 squared, which is 16. And that's this scale factor, this this S. Where I've got S, I really mean the area scale factor, because I'm looking now at how the area changed. So I'm going to use my area scale factor. Okay. Is that okay? Okay. Okay. So my surface area of my image is going to be my original surface area, which I know was 10 because I did that up above, times 16, because that's my area scale factor, so that's 160. All right, and then let's calculate from or determine from drawing. Okay, so over here what I was doing is I was calculating it based on, I know what the original one was, and I'm using a linear scale factor of 4. Let's just check if it worked. So the surface area of the image, the larger one, is, well, this end is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I have 4 sides that each have 4 times 1, 2, 3, 4, 5, 6, 7, 8. So that's 32. So this top section here has 32. And there's 4 sides that are all like that. And then, oops, plus another 16 at the other end. And if I add that up, I get 160. So oh, that was terrible happy face. So I'm happy. I got the same result both ways. Okay, that is supposed to be a happy face. It did not work. All right, so what we've discovered from this is that the surface area scale factor is the same as the area scale factor, which is the linear scale factor squared. Yes?
Why do you have 16 twice instead of just doing 2 like times 16 like you did before?
Oh, like I could have just gone 2 times 16? Yeah, I could have done that. Up in this part, I did like one end, I did the middle, I did the other end, so I was just doing it the same way. It's fine. It's however you count it up is fine. Okay, let's do a couple of examples. Use the area scale factor to calculate the surface area of a reduction. All right, so what is the linear scale factor from figure A to figure B? So figure A is the original and figure B is the image. So the linear scale factor is image over original, and it's the length of the image, like a length on the image to compare to a length on the original. So it's going to be 3 over 12, which is 1 over 4. So that's the linear scale factor for these. Run that, right? B is a quarter the size of A. What is the area scale factor? Well, the area scale factor, you could, if you wanted to, figure out the surface area of the two shapes and compare those. Or you could remember that the area scale factor is the linear scale factor squared. So it's 1 over 4 squared, which is 1 over 16. I recommend that method. That's much easier. Ethan, you need to put your phone away, please. Why don't you put it in your backpack?
Yeah, I should probably do that.
Okay. The surface area of figure A is 3,015.9 millimeters squared. Use the area scale factor to determine the surface area of figure B. So area scale factor is the area of the image over the area of the original. So I know my scale factor is 1 over 16, so that equals the area of the image is the area of B over the area of A, which is 3015.9. So the area of B is going to be 1 times 3015.9 divided by 16. And my calculator tells me that that equals 188.49 millimeters. And I've spoken to you guys about rounding, right? That unless I tell you specifically how to round something, I really don't, like I'm not going to mark you wrong on having rounded it not the way I wanted it done, because that would be unfair if I don't tell you what I want. But on a question like this, I'm pretty sure that when you use the 30.3015.9, you get the 0.49, so just leave it. Like don't, if you don't have to round it, don't round it. Just leave it the way it is. Okay. All right, let's use the formula to calculate the surface area of B and compare it. Okay. So the formula for the surface area of a cylinder is 2 pi r squared plus 2 pi rh. So the surface area of B is going to be 2 pi r squared plus 2 pi rh. So that's 2 pi times 3 squared plus 2 pi times 3 times 7, right? I just plugged those values in that I got from the drawing. Yep. And if I put that into my calculator, I get 100. Actually, let me show you how I did this, because there's a whole bunch of different ways you can calculate this. But I actually did 3 squared is 9 times 2 is 18. So this is 18 pi plus, and then 2 times 3 times 7 is 42 pi. So I added those together, and that gets me 60 pi. And then I put it in my calculator. Yeah, 188.50 millimeters squared. Am I happy with that? I'm happy with that. That's very close to what I got doing it the other way. That's a rounding error, right? That's all that is. That's the surface area of the figure figure A isn't actually exactly 3,015.9 millimeters. It's 0.9 blah 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 blah, right? There's a bunch of decimals there that we didn't do. So that's a rounding error. That's awesome. I'm happy about that. Okay. All right, let's do another example. Use the area scale factor to calculate the surface area of an enlargement. So we're just going to work this the other way. But the process is going to be exactly the same. Scale is image over original. So the scale is a length on, from figure S. So figure S is the original and figure R is the image. So if you're only going to listen to one piece of advice I give you today, label your drawings. Label which one is your image and which one is your original, okay? Just make life easier for yourself. All right, so I need a length on the image, which is 30, and a length on the original, which is 18. And if I reduce that, that reduces to 5/3. Okay. So that also reduces to 1.6 repeating, right? If you use 1.6 or 1.6, let me just go over here as an aside. This also equals 1.6 repeating, right? Which you can round to 1.7, but if you do, you're not going to get a very good answer because that's quite a bit of rounding. So anytime you get something that repeats like that, either leave it as a fraction or when you put it in your calculator, put it in as 1.666666666. Like just fill up the whole thing with sixes and then put a 7 at the end if you remember before you run out of space. But if you just round it to 1.7, you won't get the right answer. Okay, the rounding error will be too big. All right, so the area scale factor. Oh, I'm going to do some sticks. Let's see. Daryl, what's the area scale factor going to be? Or what am I going to write down first before you reach for your calculator? How am I going to find the area scale factor?
I'm not really good at doing things about them. I'm just kind of looking, dude.
Don't you have that one like freebie silly question though?
Yeah.
Yeah.
There, you got a freebie.
Oh, yeah. I don't know.
But now I'm going to make you answer it. How do we find the area scale factor?
Just say something funny.
Or it's right up on the board there, right? The area scale factor equals the linear scale factor squared,
Yeah.
right? So this equals the linear scale factor squared. So for all of you who are just writing down the answers or just reaching for your calculator, I'm going to tell you again that writing this down for every question is how you will remember it. Okay? Honestly, it does not take any more time to write this down for every question. And you will remember it and then you will work faster. Okay? I wouldn't lie to you. All right, so this is 5/3 squared, which is 25/9. And then the surface area of figure S is some number. Use scale factors to determine the surface area of the other figure. So I'm just gonna stick with the proportion. I know that my scale equals image over original. My scale is 25/9. My image is what I'm looking for. It's the surface area of S. And and on the bottom, I need the area of the original, which is 1017.9. And then the area of S is 1017.9 times 25 divided by 9. And this equals, my calculator tells me it's 2827.5, and then I need some units, centimeters squared. Okay, and I'm just going to check that the surface area of a sphere is 4 pi r squared. So it should be 4 pi times the radius squared, and the radius is 15, right? The radius is half of the diameter. So that comes out to 2827.4 centimeters squared. So that's good. Okay, that's just, you always have rounding errors when you have pi involved. Okay? You're not required to do that check. I just always do.
Is this like the surface area of a sphere?
Yeah.
Nice.
Yep. Okay. Okay, one more example. The Louvre Art Museum in Paris, France, has a glass square pyramid at its entrance. The base of the pyramid is 35 meters and its height is 20.6 meters and its surface area is 3,117 square meters. Pierre is making a model of the pyramid for a social studies class. If his model is 20 centimeters tall, how much glass will he need to cover it? So would drawing some little pictures help maybe?
Maybe.
Okay, well let's draw the original. And it's a square pyramid. Whoops. And so the trick to drawing these 3D things is you find the middle of like what is the base of your thing, and then you just go up a ways, and you just pick a spot where it's not gonna, your lines aren't gonna end up over top of each other. Okay, so there's my square pyramid, and the base is 35 and 35 because it's square, so the two bases are the same. And the height, which is this distance here, is 20.6. Oops, let's write that so you can read it. 20.6. And then the image, I'm actually just going to draw the same picture again, but I'm going to put different sizes on it. And the image, oh, all I know about the image is that it's 20 centimeters tall. It's the only height that I know. Oh, and this is centimeters, so I should put that on there because this time the units are different. So let's make sure we label that. Meters, meters, meters. And we're being asked about the surface area. How much glass do we need? So the linear scale factor, because we are given these corresponding linear dimensions, okay? So the linear scale factor is 20 centimeters. Oh, sorry, let me just do the formula. It's image over actual, or image over original, image over original. So the image is 20 centimeters, and the original is 20.6 meters. So I see a problem. What problem do we have? Yeah, Ethan.
That's. I assume the problem here is that if you attempt to turn this into a scale factor, it's just gonna be really, really long and pointlessly
You're
excessive.
you are right, but you're jumping ahead a little bit. But you're right. You are right. The initial problem is that those are different units,
Yeah.
right? You can't do a scale factor with unless the units are the same. So I'm going to change this all to centimeters. So I have 20 centimeters over 206 to multiply, yeah, move my decimal two places, centimeters, okay? And then if I make that into a decimal, that comes out to 0.0097087, at which point I go, yuck, I don't want to use that, it's too yucky. So how about if I just make it into a fraction and I reduce it? So I can divide these both by 10 and get 2 over 206, which is then fairly easy to reduce to 103. Okay. Now, because you're in the Foundations of 11 class, I will let you use your fraction button on your calculator. Do you all know how to use your fraction button on your calculator? Okay, if you don't, I will show you, but only if you swear to never tell anybody in grade 9 how to use it, or below, okay? Because it doesn't help them. They need to know how to do fractions, okay?
Like I taught the grade 9s.
Don't want you doing that. Okay, so I know that the linear scale, I'll come and show you when we're doing the other stuff. Okay, so I know that the linear scale factor is, oh, here's another thing that I do sometimes just, so you guys know that I told you I have ADHD, right? Recently diagnosed.
Oh,
But I've discovered that there's a lot of things that I do that are habits that I probably do because of my ADHD, but I honestly think they're actually really good ideas and they're good for everybody to do. And one of those is, do you notice how far separated this LSF is from the 1 over 103? Like on the paper, they're physically separated by a whole lot, so it's not obvious what that 1 over 103 is. So I would actually come over here and I'd go, yeah, that's the LSF, just to remind myself that's why I care about that number. Isn't that a good idea? Like rather than going, why do I do this when looking everywhere? I can't be the only one who does that.
we still here.
All right. So, but I'm looking for the area of glass. So I need the area scale factor, which is
The LSF
Dylan,
squared.
or sorry, Daryl. Who's gonna ask Daryl?
Oh,
It's the linear scale factor squared. Yes. So that's 1 over 103 squared, which is 1 over 10609. So can you imagine if I had kept it with that decimal of 0.0098787 and I'd squared that? I'd have like 000. It would be a ridiculously tiny number. So it's better, I think, to keep it with numbers that look like things we can relate to. All right. All right. So and I'm doing this one a little bit different than I did the other one. This time I'm going to use my I equals OS formula. The image is the original times the scale factor. So my original is 117 times my scale factor, which is 1 over 10609. And my calculator tells me that's 0.2938. Oh, wait, I did this in, no, that still works. Meters squared. Yes. Because this number here was in meters, meters squared. So I'm taking meters squared and I'm multiplying it by number. I still get it into meters squared. Okay. And then just to show you, I could have also done this using the scale equals image over original, where my scale is 1 over 10609 equals my image over my original, which is 3117. And then I'm still going to get I equals, wait. Oh yeah, sorry. Equals 1 times 3117 divided by 10609, which is the same thing as I had here, right? It's the same thing. I just get it a different way. So sometimes I'm using the image, the formula for the image, and sometimes I'm using the scale factor, and either one works. I'm not going to say one is better than the other. Okay? Okay, so that's it for the notes. There's a couple of pages, well, I guess a page and a half of practice on this. So my plan would be that we're going to do the quiz on 1.3 tomorrow. Okay? And I would really like to, if we have time today, to do the notes on start the notes on 1.4. But let's see, because we have another hour and a half of class. That should be enough time to do a page and a half of questions and some notes. So let's see where everybody is in half an hour and see where you're at. Okay?